Can we start now?
Yeah, so ma'am, we can start.
Okay, then let me share my screen first.
Mhm.
I hope my screen is visible.
Yes, it is visible.
Okay. Good afternoon, all of you. This is Soumya Pranjal, host for today's session, and today's session is about Azure networking for developers and architects. Boost your Azure Cloud Networking skills to develop and design secure solutions by Neela Madhav Mishra. About Nilamadhav Mishra, he is Cloud Lead Architect and Product Owner of Cloud Transformation Team. He is Cloud Solution Architect Azure, AWS, DevOps Technical Leader, and Cloud Blogger. And for more information, please go through his LinkedIn profile. About Fifth IR, that stands for Fifth Industrial Revolution, we are the initiative by Multi-Cloud for You to help companies and technologies to openly share their learning and get opportunities worldwide through each other's as well as through our partners worldwide. Here you can see how we are growing. We have 241 jobs, 13 upcoming events in next month, 1081 sessions completed till now, and 24 courses, 366 active speakers with us, and 8,530 certification courses are available on 5th portal, and we have 26,127 active members with us. Our relationship with Bata Global, Dell, Brilio, Tiger Analytics, Alibaba Cloud, Data Piper, Philips, Jira, and multiple small and medium companies. We also frequently engage evangelists and engineers from Microsoft and AWS. We are also Alibaba Cloud Academy partners. So here you can see few of examples of Alibaba Cloud certification courses. These are few samples. We can help you in building your knowledge, digital presence, and helping you in odd hours. When you are looking for jobs through our community, you can get all of this with a single link, that is www.thisir.com. For getting the certificate, you need to register at this event and then click on claim certificate and provide all the required information, and then you will be asked for a code. Enter the code which we will share at the end of the session to download the certificate. And for further issues, you can please connect with us at the Multicloud for You. And we have our Telegram channel, that is telegram.im/multicloud for you. Thank you so much. Now over to Neela Madhav Mishra.
Okay, thanks, Soumya. Let me share my screen and let me know once it is visible to you. Is it visible?
Yes, it is visible.
Okay. So we are going to discuss about Azure networking, but before that, I would like to thank Multi-Cloud for You team for inviting me for this beautiful session, where we are going to discuss the fundamental and also the building blocks with which an architect or developer can understand what exactly networking means in public cloud. With this session, what we will also, I will try to explain when you are starting with public cloud, what to use any of the services, what are all checkpoints that you should definitely consider with respect to networking. So these are all points that I will cover. I will not use much of the Azure architectural jargons. I want to be very straightforward, and also in layman point of view, I will try to explain so that you can understand it. And once you understand it, then no jargon can help you out. You can do it by yourself. So that is the mindset that I'm having, and also I'm trying to enable that throughout the community. Yeah, I'm also a cloud blogger. When I say cloud blogger, that means I have a YouTube channel known as Public Cloud Design Tips and Tricks. You can find it in YouTube, and then there we publish every weekly, multiple small videos with respect to design. Now, over to networking. So the first question which will be coming is like, what do you need? Why do you need networking? And especially when we talk about networking in public cloud. So as we are coming out of the era of on-premise system, that means if you think about any private organization or public organization, they have their data center where they have the data, they have the hardware, and inside the hardware they have the servers, they have the data, they store everything. That was the old mindset, old school technologies those private organizations were using, in the old world. As the world is moving towards public cloud era, everybody is trying to utilize the public cloud as a service. That means each capability of your data center can be available to you all across the world, whichever corner of the world that you are sitting. You want to realize that capabilities in form of service. That means you do not have to have a data center, you do not have to rent a building to keep it as a data center. You do not need a hardware to store the data. That is where public cloud is coming, and it is telling you guys what you need. You let me know, and I will deliver to you to your laptop or to your organization via service, and I will take care of that particular, the data center or the capabilities that you are looking in your own data center. And now, when we are talking about public cloud, that means the word public itself is a bit scary, right? You will scared of it. Okay, it is public. Then how can I store my private data? How can I make sure my data can be only accessed by me? How can I make sure my data will be completely secure in that public environment? That is where the networking concept is coming to picture. So public cloud will provide you a private network where you can host your services, you can connect to your on-premise system, you can connect to internet securely. So if we translate in a layman point of view, to establish secure connectivity between services, that means you can see here between services from a app service to SQL database, or to internet, that means from this app service to internet, or to on-premise, that means this app service to your on-premise data center, which is where you have multiple other applications. That is where the networking or public cloud networking features are coming to picture. So that is the need behind networking. Now let's try to understand what are all different networking services these public cloud service providers are providing you. So if you look into this providers, then first type of service is a connectivity service. As the name suggests, it's a connectivity service. That means connectivity between the services. It can be a app service, it can be a Kubernetes service, it can be a storage account. That means that connectivity will be provided by this set of services. And if you check what are all services which is available with Azure, one is virtual network, second is one, third is VPN gateway, and many others. Second is application protection service. That means if I am hosting a Java application, if I am hosting a .NET application, or if I am hosting a CSAP application, and I am hosting that application in public cloud, that means in a data center which is not in my control, which is in the control of public cloud provider, that means it can be accessed by anyone else, right? So that is where the application protection service is one of the capabilities which has been provided by Azure, with which you can secure your application. And one few of the services, which I'm going to tell it now, like DDoS protection. That means you can protect your application from a DDoS attack. Firewall capabilities. I will talk about firewall in another slide, definitely. WAF capabilities, web application firewall. That means you can restrict your capabilities with your firewall within your application layer. NSG, Network Security Group. LB, Load Balancer. That means how you can load balance your services. private link endpoint, which also we are going to discuss about it in the successive slides. So these are all application protection services. First is connectivity service, second is application protection service, then the third service, application delivery service. What are all examples? Like CDN, second is a front door, third is application gateway, and fourth is load balancer, this type of stuff. Then you will see, you will ask me, Neil, you are telling application protection service and application delivery service. What are the difference between these two? Application protection service, the if you check these two statements from a layman point of view, the first one states protection, second one says delivery. That means the first type of services are the services which protects your application. The second set of services which make sure your traffic to your application will deliver in an efficient way, that is known as application delivery services. So CDN, a front door, application gateway, load balancer. So if you, I will try to explain bit of difference between these four types. Let's start with load balancer. So load balancer is the service which is available in Azure, which is very specific to a zone. That means the data center which has been provided by Microsoft Azure can be categorized into a zone. So if you think about the data center in Europe, in my area, like I'm working in Netherlands, so in my area, the data centers, the zones which are available like West Europe or East Europe, this type of zones which are provided. So inside those zones, if you want to load balance your traffic, you are having a web application, you are hosting this to a web application, one of web application in two different machine, and you want to load balance your traffic so that the machine can efficiently work, then you can use the load balancer. That means it is within the zone. Application gateway is a network layer load balancer. That means if you want to load balance the traffic in the network layer, then you can use the application gateway. Application gateway has lot more powerful feature like web application firewall integrations, DNS resolutions. There are many other capabilities also application gateway is having. Then the front door is more towards when you want to route the traffic between region. That means I am hosting a application in India, and the same application in India region, and the same application I am hosting in Europe region, and I want to load balance the traffic so that in case of disaster in India or in Europe, the other option will be available. To route the traffic between the region, you have front door. CDN is more towards the caching capabilities. Okay, so where you can cache your traffic or response, and you can, the CDN service will able to give you the response without calling the backend. So that is the capabilities of CDN over front door. So these are all application deliver service. That means we are considering a kind of routing service which is related to route your traffic between the application servers. Then the fourth one is network monitoring. When we are talking about network monitoring, so then again, as I said, like, you forget about the jargons. You, if you try to understand these keywords, then it will give you the answer itself. Network monitoring means there will be some tool or some service which will monitor your network. That means who is accessing your application, who your application is going, routing the traffic to where, who has the user, or who is the what is the load that is coming to your network. This type of monitoring is done by the network monitoring services. And Azure have also very powerful network monitoring services, which is a kind of network watcher, Azure monitor. This type of services are kind of monitoring services. Now we understood all four type of network services, right? One is connectivity, second is application protection, third is application delivery, fourth is network monitoring. Now let's try to understand the basic concept of Azure networking. So this is the point I would suggest all of you give the focus. If you really understand this concept, it is not only with Azure, also AWS, also Alibaba, also Google, everywhere you can realize your design in an efficient way. The core fundamental behind designing each application in all this cloud is same. And that is the fundamental that I'm going to talk now. At the end, when you look into a public cloud, you will have a public cloud subscription, And the public cloud subscription has two segregation. One is private area, second is public area. So from a layman point of view, let's try to understand. You have a public cloud, and this public cloud has two segregation. One is private accessibility. That means it is completely accessible to your private organization who has access to it. And another is public accessibility, where anyone can access, anyone can view the service. Okay, they may access it, they may not access it, but they can view it. So this is the main segregation behind all the cloud, public and private. Now, once you have the public and private, then either you want to connect to your on-premise or you want to connect to your internet. Okay, if you segregate this three part into three section, one is on-premise, second is public cloud, third is internet. In internet, you have multiple third-party SaaS solution, you have multiple other organization that you want to connect. These are all which is outside your public cloud, that will be considered as internet world. Okay, so now let's try to focus on this, the middle block. What is exactly is this? So within Azure network, if you, as I said, like if we segregate into two hubs, one is Azure public, second is Azure private, then in that case, private is nothing but a virtual network. That is the base definition you can say. When you create a virtual network, it will be giving you a set of private IP and also a set of rule which will make sure this IP, these rules, or this particular private space can only be accessible by the people or by the organization who has access to it. Rest of the things can be considered as public, Azure public. That means this is a area where everyone can access it. Again, as I said, like we'll talk about in a layman point of view. You have Azure has a data center, and inside the data center they have racks. That means they have hardwares which are stored in racks. Okay, so if the rack has been categorized as private, that means that hardware can be accessible by the private network. If the racks are being categorized as public, then that rack can be accessible by anyone who has access to that data center. So that is the segregation between public and private. So simple one line, if it is a virtual network, it is private. If it is not a virtual network, it is public. Now the next question will come. Neil, what is virtual network? Then the virtual network definition is very clear. Virtual network is a kind of, again from layman point of view, virtual means virtual. That means you cannot touch it, you cannot hold it. Rather than it can be realizable by the form of a set of IPs or a set of rules known as network security group. So who can access to this virtual network? When you are creating a virtual network, it is a kind of service which is available in Azure. Who can access this virtual network? That rule can be defined in a network security group. So in the network security group, you can define who can access this application. Which application? The application that you are going to host within the virtual network. You can think about a simple application, a Java based web application, a Spring Boot application that you want to host inside the virtual network. Then who can reach this Spring Boot application? That will be defined in this NSG rule. So this NSG rule is nothing but the door to your house. If the virtual network is your apartment, then the door to this your apartment is the network security group. Via this network security group, you have a gatekeeper who will say, okay, you have access to this building, then you can enter. You do not have access to this building, you cannot enter. So that is the goal of network security group. Now inside this apartment, you have multiple houses, multiple chambers or flats, and these flats are nothing but the subnets. And like Neil is staying in this flat, and my neighbor is staying in this flat. So I have my own door, my neighbor has also another door. I want to go to my neighbor, then in that case I have to open my door, and then I have to enter my neighbor's door, and my neighbors needs to allow me to come in, right? That he can define in his door, okay, Neil can enter to my house. Or same also applies here. If my neighbor wants to come to my house, then I have to define, okay, my neighbor can come to my house. Otherwise, to define that, I have to get the approval from my wife. Otherwise, my wife will not let him come inside my house. So that is what the NSG rules, which are nothing but the rules that you are defining in your virtual network level or in your subnet level. Okay, this is what the NSG rule. Now the example which I gave, like who can come in, who can go out. This is what we call it as inbound and outbound. So when I want to go to my neighbor, that means from my flat to my neighbor's flat, I want to enter, then that is outbound from my flat to my neighbor's flat. That means subnet 1, which is nothing but a logical segregation, my house, to subnet 2, which is a logical aggregation of my neighbor's house, that we call it as outbound traffic to my house or from my house. Now my neighbor want to enter to my house, that is a inbound traffic to my house. That means my neighbor will have the access, that he can define, he can enter to my house, and that rule can be defined here. So now coming back to the architectural jargon. So my house is nothing but the subnet. My door is nothing but the NSG rules, and the rules which I am defining, that means this subnet will be assigned with a private IP, and this subnet will be assigned with a private IP. So I can define the rule in the NSG rule. The source is subnet 2, the destination is subnet 1, and the port is 80 or 224 or whatever port that you want to enable, that will be defined here. If the request is coming from this source to this subnet, then only it will be reachable. If any other subnet wants to reach this subnet, then it is not reachable. The same layman point of view, my neighbor can enter, but my other neighbor, maybe I have not defined, I have not got my approval from my wife, so he cannot enter to my house. And that is what the rules. So if you think about the virtual network, the inbound and outbound are nothing but the rules where you define who can enter, who can move out. Now the outbound and inbound again to this virtual network, that means uh, from this virtual network to my flat, who can enter outside the flat itself, outside the apartment itself. So that can be defined in this NSG rules. And this NSG rule is the aggregation of the people who are living in that particular apartment. So if subnet 1 and subnet 2, they allow this NSG rule, then only somebody can enter. If the aggregation is not there, if none of them allow anyone, then nobody can enter. And that is what the NSG rule on the virtual network layer. So let's clarify again. Virtual network is a set of private IP inside which you host your application. Inside a virtual network, you have multiple subnet. You can define the interaction between the subnet or the traffic between the subnet via the NSG rules. And also you can define the NSG rules in the virtual network layer, who can access it, how can access it. Inbound is who somebody is or traffic is coming to your virtual network or your subnet. Outbound is traffic is going out of your subnet to another subnet or to outside the virtual network. That is outbound. Simple concept. Now, the next thing is, you will ask me, Neil, is it like when I will create a virtual network, in that case itself, I can, if I will not define an NSG rule, then what will happen? I will not define any rule. That means I do not have any door. I have a, I have a entry point, but I do not have any door. That means anyone can enter into your apartment. And that is what happens. When you create a virtual network, you do not override the NSG rules. You do not override. There is also another concept known as route table. That means when you understood these rules, you have a orchestrator who can order it, or a kind of routing mechanism who can override your default rules. That means you have to define that in the NSG rules, then only it will be in control, then only it will become private. Otherwise, if you are making your NSG rule, you are creating a virtual network, you are not defining, that means outbound traffic to the to the internet is always open. So whenever you are making a request from the subnet, then it will never land here, rather than it can go out directly. Okay, I do not have to go here, I can go outside. So that is the key, that is the routing mechanism that is available in a route table. So route table is a definition where you define, okay, I want to go to this subnet, I want to stay go to this internet, or I want to go to any other virtual network, that can be defined in the route table. And who can reach out and how it can be handled by the NSG rules. Okay, so this is the concept of virtual network, subnet, NSG rules, inbound and outbound. Now let's talk about on-premise and internet connectivity. When we are talking about on-premise and internet connectivity, that means, again, looking into this diagram, you are in Azure private, you want to reach to on-premise, okay, which is here, and you want to reach to Azure, to internet. In that case, what you can do to reach your on-premise, Azure has multiple solutions which lie over a express route. Express route is nothing but a third party vendor who provide a secure connectivity from Azure data center to your on-premise data center. And this can be done via VPN device, VPN gateway. So if you use VPN device and VPN gateway, that means the network traffic which is going from Azure private to your virtual net to your on-premise system will be always encrypted. So you will have to have a VPN device in your on-premise data center. Then the third party vendor will pull the wires from your on-premise data center to Azure data center, and then the VPN gateway will make sure the connectivity will be always secure or encrypted. So that is how you can make a secure connectivity from your private network to the data center. And same, if you want to go out of the the private network to internet, that means you want to define a kind of firewall capabilities. That means which rules are allowed, which rules are not allowed. There are two types of rule. One is application specific rule, another is network specific rule. So that can be handled by the Azure firewall. Firewall means, you can think about, again, from layman point of view, when you are using a laptop in your house, then in that case laptop has also a firewall, right? Which has a Windows machine has also a firewall. So the same firewall concept has been deployed here, where you can define how and where you can route the traffic and which traffic should be allowed, not allowed. So that is the use of Azure firewall. Now we understood private and public connectivity. Sorry, private and on-premise, private and internet. Let's talk about a public and private connectivity. I have a virtual machine which is hosted inside a virtual network. And that virtual machine wants to reach to a service which is hosted in Azure public. That means which is outside my virtual network. How can I make a secure connectivity to Azure public? That is where two solutions which is generally provided by Azure is service endpoint, and second is private link endpoint. So with private link endpoint, when you are making to your PaaS service a call, that means the call will be completely in the private route to Azure public. So no one can access that traffic network. The traffic will be completely in your network. That is the capability of private link endpoint. But when you do not, and also it comes with cost. When you want to use service endpoint means it will make sure the traffic will reach to this network securely, but it never goes privately. That means it goes via the Azure backbone network or via the internet route. That means, if you compare private link endpoint with service endpoint, private link endpoint is much more secure, much more private to your organization. As in layman point of view, private means completely secure, and service endpoint means it will be secure, but you have to do lot of work in the PaaS service itself. So in this service also, when you are going from the private network to the PaaS services, you can define who can access this service, which sources can be allowed, which sources cannot be allowed. So most of the PaaS services has their own firewall. Okay, that is the firewall which is linked to this service, and there you can define this private link endpoint should be allowed, or this service endpoint should be allowed. Otherwise, there will be another organization who has their private link endpoint. They can access your public PaaS service, and they can also reach this PaaS service, right, privately. So for that you need to have your that particular a firewall in that service where you define who is your source. So as we understood, the inbound call to this app service can be controlled over this firewall, which is Azure App Service Firewall. Now, the service app service now we are talking, it is a multi-tenant app service. That means it always sits in public. But there is also another flavor of app service which is available known as app service private, which is single tenant app service which sits inside your virtual network. As you know, you are using private services, that means you have to pay with the cost. So you can decide whether you want to use a a pass service which is sitting in public, or you want to use a pass service which is sitting in your private, or app service which is sitting in your private. Based on your NFRs, you can decide that. We talked about the inbound connectivity to this app service. Now let's talk about the outbound connectivity. Let you are having a Spring Boot application. You want to store the data in a database. In that case, and the database, let we are thinking like, okay, the database is in on-premise. So from this PaaS service, and we know from this private network via the express route, the on-premise secure connectivity is there. So what we can do, you have to reach to this private network, right, from your public site. So that is where app service, multi-tenant app service comes with a delegated subnet. That means all the outbound traffic from this app service will be always routed to this delegated subnet. I am giving the example of this app service. You can take the example of any other PaaS services. They have same kind of connectivity. At the end, you have to see when you are touching or you are using a app PaaS service, that means a public service. You have to say what is the rule for the inbound connectivity, what is the rule for the outbound connectivity. If you understand these 2 points from Azure documentation, then you are smart enough to handle that service the way you wanted to. And that is where we call it as Azure application network connectivity, right? So we talked about the third type of service, where application connectivity service, where you define which service will be routed to where. So this is how a public service can be connected to a private service. Now let's talk about a connectivity scenario. So I want to host a Java based web application which is in app service, and from this app service I want to store the data in SQL database which is also in public. So if you make a call directly from this app service to this SQL database, which is also in public, direct to direct, in that case, it is going via the public network. That means anyone can trap it in between. Anyone can read it in between if they trap it. But when you handle your traffic from your app service to a delegated network, that means all the traffic from this app service to this delegated network will be encrypted or will be securely connected to your private network. And from your private network you are going to private link endpoint, and via this private link endpoint you are reaching to this SQL service which is also a secure connectivity. Then the entire traffic from this app service to this SQL network will be completely restricted or private. That means I understood the outbound connectivity from this app service. I understood the inbound connectivity to the SQL service, and that's where the connectivity has been handled securely with the network. And that is what we call it as net architectural network designing of an application on pass to pass connectivity. So you understood, from a PaaS service to this PaaS service via the virtual network, you are in completely control. There are many other things which can be done with many other services. That's where you have to read through that service. You try to understand the outbound connectivity pattern, inbound connectivity pattern. Then after that, you can define what should be the way to connect them each other. So this is what we call it as PaaS connectivity. Now, third one, we are connected, but how we can trust you? Okay, you are the app service that you want to, I want to allow you. That is where another concept which is there known as managed identity. Managed identity means when the PaaS service will be created, a identity will be created in Azure AD, and with this identity, this PaaS service can trust this SQL database. That means the SQL database will create a user based on the identity which has been created by PaaS service. That means app service. That is what we call it as authorization authentication mechanism via managed identity. I am talking on networking concept, so I do not want to deviate here. But if you really wanted interested on managed identity, go through Azure portal and you will Azure documentation, and you will find fantastic documentation via Azure regarding managed identity. So let's focus back to our networking concept. Now let's think about another scenario, okay, where you have two app services. One is hosting a front end, second is hosting a back end, okay, and you want to connect to this front end, and then from the front end there will be a call which needs to be established to this app backend service. And from this backend service, I want to call this, I want to store the data in this PostgreSQL. I want to make a call to my on-premise system. I want to make a call to internet. How can we realize that? So that is where we are coming up with a solution known as app service with a delegated subnet, that is for the outbound connectivity. App service to route the traffic between the app services, you can use application gateway. Application gateway is a network layer load balancer. Again, if you think from the layman point of view, application means application, gateway means it's a kind of gate where you can traffic or route your traffic or load balance your traffic. So that is where application gateway is playing a picture, where you can route your traffic from this application gateway to this private link endpoint. As you see here, application gateway is sitting inside the private network, and from this private network you want to reach to this public network. That means an inbound call to the public network. You are going via the private link endpoint. And from this private link endpoint, you are reaching to this app service. That means your front end. And after the front end calculation is done, then it is making a call to your backend via the delegated subnet. That means this front end is coming to this delegated subnet via the private link endpoint. Again, it is going to this app service. But if the app service will talk to each other like this, straightforwarding public to public, then it is not secure. And that is where the delegated subnet private link endpoint again to the app service is coming to picture. Same concept applies here. When you have this backend ready, that means you are doing the calculation. You want to store the data in this PaaS service. Then again, you will go to delegated subnet via the private link endpoint. You can reach to this, PaaS services. If you want to understand, okay, can I have a single subnet where I can have multiple private link endpoint? Yes, you can do that. Also, you can segregate them. You can have multiple subnet for one subnet for private link endpoint to app service, one private link endpoint to this PostgreSQL server. It will be completely up to you. I am defining what should be the connectivity pattern. Now, based on your NFRs, you can define that. Again, let your backend service, that is this app service wants to make a call to on-premise. Then what you can do, the outbound connectivity will be coming to this delegated subnet. In this delegated subnet, NSG rules you can define. Okay, from here route table you can define. From here you go to this VPN gateway. Via the VPN gateway, via the express route, you can come to your on-premise. That means this public service reach your on-premise via your private network securely. And again, you want to reach to internet via this firewall, this public subnet, sorry, this public app service reaching to your delegated subnet via the firewall. It is going to internet. That means it has been tracked here. You can track how the traffic is going to the internet via this Azure firewall. Okay, this is how you can handle the app, a web app application, a 3-tier web app application via this front end application, back end application, application gateway to the different app services. Now, hub spoke model. What is hub spoke model in networking? So if we think about the previous diagram, so if we create a VPN gateway or a a Azure firewall in the virtual network, so there are two teams in your organization, or around 30 teams or 300 teams or 400 teams. Each team has their own virtual networks. That means, are we going to create the 300 or 400 VPN gateway for all this virtual network per team to reach out to on-premise? No, right? We can place these services, which are mostly costly services, in a separate network, and that is what we call it as a hub network. If you check the Microsoft documentation, they have clearly explained in the hub network you can centrally place those services, and the spoke networks is nothing but different teams network who can peer with this hub network. so that the traffic can reach to this hub network, and via this hub network you can go to internet, or you can go to this on premise, that you can define in the appliances which has been installed in the hub network. That we call it as hub spoke model. If you go to any Azure interview, any interview which is related to Microsoft Azure, you will definitely asked about hub spoke model. Can you define hub spoke model? You can define that, okay, with hub spoke model, this is the benefit, that you can reuse your appliances, you can reduce your cost, you can re-platform, or you can reuse your services efficiently, so that everybody can get benefit out of it. That is what we call it as a hub spoke model. Spoke means different teams. Hub is a centrally placed location where you can do some kind of central work for your organization. That is what hub spoke model. Now, high availability. We talked about application gateway, load balancer. Now let's think about a front door service. Now you'll ask me, Neil, you talked about application gateway. Now why do I need a front door? Let you are thinking about hosting a CIA one-on-one application, and you want to provide that application as 99.19th time 9 availability of that particular application. How you can do that? Azure is telling you, then in that case, deploy your application in two different regions. That means if there is a natural calamity happening to one of the region, and your data center is going down, or your availability zone is going down, then your traffic should be routed to this other region. That is what we call it as high available solution. This is also one of the important question which has been asked during your Azure interview, like what is the difference between a front door and a application gateway? Front door is a very region zone specific or region specific service. Sorry, application gateway is a very region specific service, whereas front door is outside the region, where you can route the traffic, or load balance the traffic between the region. Okay. And also front door has the WAP capabilities, where you can have the OSWAP rule, WAP, the rules of DDoS attack and all that also can be defined here in this WAP. So Azure front door is the capability which will route the traffic between the active region, and also you can load balance it. Okay, 60% to this one, 40% to this one. You can also manage that. The what you can say, weighted routing mechanism also can be installed here. Now from this application you want to make a call to a PaaS services. That means your PostgreSQL service, as you understand in the previous diagram. Via the private link endpoint you can reach it here. Via the VPN gateway you can call to on premise. Via the Azure firewall you can reach to this internet. So the concept is remain completely same, where it is only load balanced via the front door. So that is how you can make your high availability between the applications. Then you will tell, okay, Neil, one more thing. I am syncing the data. I am sending the data, 40% data to here, 60% data to this PostgreSQL server. So they are in two different regions. How they will sync? Do I need to sync the data? And that is what the beautiful capabilities of that particular database PostgreSQL is having, GRS. That means if you enable that, that means the region level syncing will be also done. That means those two data can sync to each other and share the data, and should have always one set of data with it. So this is the basic definition, or mechanism where you can do implement a 3-tier web application with regional level failover capabilities. Again, I said, like, it varies from design to design, but all the design are sitting in this framework only. You have an active region, you have a passive region, you have an active region. In case of passive region, the application will remain down, and when the active region will fail, then the passive region will turn up. So this is how you can implement it. You will always have a private network, you will always have a public network. You can establish a public to private connectivity. So this is how you can establish it. Now we will talk about Azure firewall. You will ask me, like, Neil, you talked about Azure firewall a lot. What exactly benefit that I can get from the Azure firewall? If you check the latest firewall that Microsoft Azure is having, in that firewall you can do TLS inspection. That means if you know about TLS inspection, that means you can inspect on the traffic level data which is coming via the firewall or going via the firewall. IDPS URL filtering, that means you can filter it out. Okay, out of 10 URLs, which URL should traffic routed to where? That also can be done. Web categorization also can be done there. Now, with the latest Azure firewall, as we understood the hub spoke model, you can place the firewall in the hub network, and the spoke network, which is having your different application, they can be paired with the hub network, so that all the traffic that they want to route to internet, let in this traffic, traffic is denied by default. You have to enable a public connectivity to internet, that you can define in the firewall. And from this firewall, let you want to establish a secure connectivity to on premise, that permission also you can define via the vnet and v1. That is also a new service, new capabilities which is available. So at the end, firewall can be a, a kind of hub where all the connectivity, all your central connectivity can be routed via this. And your security team, who are the building blocks behind the public cloud network, can always inspect, okay, what traffic is going in, what traffic is going out, who is the owner, what is the user, what is the port, what is the connectivity, what is the bandwidth of the traffic. Everything can be inspected in the Azure firewall. So this is the beauty of Azure firewall. So the services that we have discussed today, if you come from top to bottom, let's go to the first slide. So we talked about connectivity services, we talked about application protection services, we talked about application delivery services like front door application gateway, network monitoring services. I think I have not covered this one. Let me give a quick glance here. So network watcher or Azure monitor are the also kind of services where you can always track the networking traffic to and from your virtual network. That means not on the firewall level, or not rather than it will be available on your virtual network level. That means in that virtual network, let you are hosting a virtual machine inside it, and you want to watch the traffic which is coming to your virtual network, virtual machine, and going out of the virtual machine. That can be done by the network watcher. So network watcher is one of the smartest capabilities, I can say, which has been provided by Microsoft Azure, which has that capability to inspect your network, to track your network traffic from and to your virtual machine. So yes, these are all networking concept I thought like to pass it to you. If you really translate the concept that I have explained to all the services, all the organization, the most of the organization are implemented or followed this type of mechanism, hub spoke models, private public network, or the connectivity to the firewall via the VPN gateway, via the express route to on-premise. These are all things which is the root of the connectivity, or new root of the networking behind the design phase of any private organization who are really utilizing public cloud in an efficient way. So that is how public cloud is also getting the trust from the organization. Guys, you are using public cloud, you are getting the services via the pass as a service, the hardware as a service, but at the end you can also control it with the capabilities. So so yeah, that's what I thought like to share with you. There are a lot of other concepts like route table, private IP, CDR, CIDR range. Like, okay, what should be, if it's a slash 28 IP, then how many IPs that I'm going to get? If it's a slash 24 IP, then how many IPs that I'm going to get? There are many concepts which is lying behind it. I would always recommend, go to Azure portal, open Azure networking, and go through all the building blocks. But when you're thinking about design, remember this fundamental concept, the apartment concept, the subnet concept, the wife example that I have given regarding the approval, that will really help you out to design your application efficiently, effectively, securely. So yeah, that's what about me, about the concept. You have any questions?
Thank you so much, Neil, for a great session, and thanks to everyone who joined. Let me share my screen again for the certificate code. Uh, Guys, this is the certificate code. You can use this certificate code for downloading the certificate. And if anyone have any question, please ask.
I saw some question which is regarding to like some multi-tenant app service in Azure. Okay, uh, let me uh, let me give a quick explanation of multi-tenant app service. As I always try to explain it on a layman point of view. So multi-tenant app service means, if you think about a data center, okay, where you are hosting your app service, you are defining, you're creating an app service. So every data center have different hardware racks, right? And each hardware racks, when you are defining a service as multi-tenant, that means the service will be created in that particular rack, and that rack can be accessible by other private organization as well. That means multiple tenants, each organization, each tenant can access it. So that is why it is in the public area. Okay, if you talk about multi-tenant, any multi-tenant, not only app service, any multi-tenant service, when you talk about it, that means it is sitting in that particular area. Okay, and you anyone can access it, and that is where you have to implement the private link endpoint, service endpoint, delegated subnet. These type of concepts are coming. But when you are talking about a single tenant app service, that means that particular hardware can only be accessed by that particular tenant. No one else can access it. That means it is completely private to that particular tenant. That is how you can segregate each multi-tenant to single tenant service. And every multi-tenant service should have a connectivity, private connectivity concept, and also the outbound connectivity concepts. So that's how you can, you can always define it, a multi-tenant service. You really wanted to know about it, I would highly recommend go through the Azure documentation, but think about those lines that I said to segregate a multi-tenant and single tenant service. Then another, I hope there will be some practical application to explanation. There are multiple practical application, which is currently available in Azure world. I could have also given some more application, but I didn't have much time. With 1 hour, it is very difficult to share the concept and cover the application. But you can definitely find a lot of application. But all the application are sit behind these concepts. So these concepts are the root to these services. Can an Azure AD tenant be associated to multiple Azure? Multiple Azure. I'm not very sure what do you mean by multiple Azure, but let me try to translate if I understood your question correctly. Yes, definitely. When you have a Azure AD and tenant be associated to multiple Azure services, that can be done, but there are also few limitation and few cautions that you have to take care when you are defining a tenant for multiple services. But generally, like, if you think about any private organization, they have one tenant. That tenant can be shared with multiple services who are sitting under that particular tenant. So it can be definitely considered, but you need to make sure it should be in line with your design aspect that you're building. So yeah, I think that's it from my side. I don't think we have any more questions. Thanks a lot, Soumya, for hosting the show. It was really nice to share the concept with a good audience. And yeah, if you have more questions, guys, feel free to reach out to me over LinkedIn, and I would love to answer your questions. We can definitely have a good connect there.
Okay. Thank you so much, Neil, for a great session, and thanks to everyone. For certificate, it might take a few days to get it once we upload the recording of the session. And we hope you all enjoyed the session. Thank you so much. Have a good weekend, all. Thank you.